Maxel OSS is my startup through which we are providing open source implementation services. So what is free software and what is open source? So when we talk about free software, many a times there is a conception that it is a open source software is a free software, but majority of the softwares are open source and free, but it is not the exact meaning. The open source means something different than the free software. Let us see what. So I'll just keep the software history. So open source has its source code available publicly. That means anyone can study the code, modify it, redistribute it under specific licenses. And you can see the examples like Linux operating system, Python programming language, Firefox browser, PostgreSQL database, FreeCAD we have already seen for 3D modeling, analysis, etc. So all these examples are related to open source tools which are available in today's world. If we take an engineering analogy, the proprietary software is kind of a sealed machine where you can't do anything, just use it. Whereas open source tools is a machine with all the drawings and ability to modify. So in addition to using the machine, you can modify its usability also. There are different licensing terms for open source, but obviously, as a user, we don't need to worry about all these licensing terms. We can just see that yes, it is an open source tool. We can download it and use it to understand how it works. So the question comes is, are the open source tools reliable? Obviously, because if it is open source, it is free, then is it reliable? So to answer this, we can say in our today's life, the Android phone which we are using is based on Linux operating system, which is open source. Even internet today, you can see the statistics here. Overall, the sorry, overall you can see 96% of the top 1 million web servers are operating on Linux operating system, which is open source. So this is the power of open source technology, and it is already being used in a most reliable way. Otherwise, internet would not have been working. So this is the the reliability is already established through open source tools. And coming to today's era, which is AI and data. So in data science and AI also, you can see this slide we had taken from Linux Foundation. It says that more than 80% of the aggregate developments in the AI and etc. it is done in open source technology. Then why open source technology struggles if it has so much benefits and advantages? So the first thing is limited awareness because many capable tools are available, but they remain underutilized due to lack of visibility to the end user. Obviously, the developers and at the system level, things are available, but at the user end, the awareness is very limited. There is also a learning curve because initial setup and workflow understanding takes time because these softwares are not commercial software. They are not marketed the way commercial softwares are. There are no specific training classes for them. So there is a learning curve which keeps it in a struggling mode. And support is not centralized. You don't have one thing, one company, one contact salesperson who is responsible to answer you. It is driven by the community and self exploration. So these are some of the things where we feel that open source tools are struggling, but we are here to study the benefits and to break these constraints and start using open source tools. So today with us we have Mr. Sumanto Kar. He is MTech in Industrial Engineering and Operation Research from IIT Bombay. Currently, he is actively involved with FOSSI project. He will describe what is FOSSI project and contributing to the development, integration, documentation, and outreach of eSim. So his focus is on strengthening the open technical ecosystems, enabling responsible engineering workflows, etc. So, with this, we are good to have Mr. Sumant Okar, who is part of the development team. So, he knows the back end of the software, how it is developed, how it is used. So he'll be able to enlighten us with the usability of the software and some live demonstration by his colleague Mr. Varat Patil. So welcome Mr. Sumantokar and Varat Patil. And with this, I conclude this my talk, and over to you, Mr. Sumantokar.
Thank you, Himanshu, Mr. Himanshu, and IEI for the warm introduction. So, may I share my screen?
Yes, you can.
Is my screen visible?
Yes, yes.
Okay, great.
Yes.
Yeah, so welcome to this webinar, and thanks to IEI for organizing this webinar, and thanks to Himanshu as well for inviting us. So, yeah, about me. So, as Himanshu said, I did my MTech from in Industry Engineering and Operational Research from IIT Bombay in the year 2025, and B in Electronics Engineering from Mumbai University. I'm also associate member of IEI, what we call as AMI, and my interests lie in contributing to open source EDA tools, and I'm actively involved with the FOSSI project since the last couple of years, and contributing to different to eSIM and different other open source platforms. And yeah, so here is my IDs, and you can
One more,
connect with
Mr.
me.
Sumanto. Sorry, I would like to interrupt you.
Yeah,
Mr. Prabhu sir has connected with us, and I would like. Uh, eh, he is the PI for this FOSI project at IIT Bombay. And Saurabh ji, if you can unmute Mr. Prabhu sir, he is on the list of participants. We welcome you, sir, to this webinar, and we want to hear from you for 2 minutes. Hello,
Kindly repeat the name, sir. Prabhu, full name, sir.
Prabhu Chandra.
Prabhu Chandra, just a minute.
Prabhu Ramchandra.
I'm not finding his name. Himanshuji, I make you as host. You kindly see who is that person. You can unmute him.
Hello, Prabhu sir, are you connected? Hello, hello.
I'm not finding his name. I make you host. So kindly, if you can see,
Okay, let me see.
Hello.
Yeah, he is here with Mr. Varat Patil. Okay.
Prabhu sir is there with us.
Hello, hello.
Yeah, good afternoon, sir,
yeah, you're
and
audible,
thank you
sir.
very much for connecting with us today.
Yeah.
And we would like to hear from you.
So I actually joined on the link that had no controls. So I think it came through the webinar link, so you couldn't see me. So I thought I'll just come here and directly talk. Yeah, so I'm Prabhu and I'm a professor of aerospace engineering, but I'm the PI for the FOSSEE project. And so eSIM is like one part of FOSSEE's initiative. So FOSSEE is about free and open source software for education. And this project has been active for about 16 years now. It's an MOE funded project, and we have several verticals covering a whole range of different open source software. And I believe this is the first in a series that you're planning with IEI. So that's really nice to hear. It's an excellent platform for dissemination of open source tools. And in particular, I'm very happy to see that it's eSIM that's the first, simply because eSIM has the potential. This is an area that's in India currently. There, the number of designs or the number of chips, ICs that India produces is practically zero. It's not very, very small. In part because we have only one fab, which is the SCL Mori facility, and we're getting more fabs now. So with the new semiconductor mission, this is changing rapidly. So in the next 2-3 years, there's going to be lots of demand for engineers with these technologies, and also exploring other things with respect to how to use open source tools to be able to generate, do tape outs through any of the fabs in the country. So this is like an ideal time for you to have started such a series of webinars. And I'm really happy that eSIM is the first one. So eSIM is one of the verticals of FOSSEE, and it allows you to do mixed non-analog digital kind of analysis, and do the you can look at it from devices or from the VLSI point of view, and eventually take it all the way down to actual hardware. We have actually had some really nice success stories of people who've taken eSIM workshops and then gone on to build their own designs and then do a full tape out. In fact, there was a recent LinkedIn post where they first started this project through an eSIM workshop that Sumanto and his team ran. So this is really very nice to see that you're starting with this. And as I said, this is an extremely exciting area, given especially the current context in the country. There is a dearth of engineers who know the open source stack. Most people in this industry especially are used to extremely expensive commercial tools. So Synopsys and Cadence are two of the big names. I think Siemens also has some tools. And all of them are upwards if you're not in academia. So all of these organizations tend to give you tools in academia at a very easy or very cheap rate, because then they get all the students hooked into those tools. And then, when they go out of the thing, they're forced to use those tools because that's what they're trained on. So one of the things that we try to do with FOSSEE is we try to break this. We try to say, okay, if you want to learn the basics, you don't need an expensive commercial tool, which allows this to be done by anyone, which means you can be in college, you can go home for your summer holidays. You can, in principle, design a chip yourself. And ultimately, it'll be great if we could also do a tape out, which is still a ways away. It's not today, may not be immediately possible, but we're trying to see if that can also be made. We're going to work with other people in electrical engineering, and we'll also try and work with Tata Electronics and others to make sure that this is possible. So the aim is we want to be able to facilitate everyone to be able to do these kind of things. And this, I believe, is like extremely important because it aligns perfectly with Make in India. It aligns perfectly with the semiconductor mission. And it's the need of the hour. Our country has other manufacturing units. In fact, packaging and other things are easy to do in the country. There are facilities for it. But fabs, we have not had so far. So now this is changing. And eSIM is extremely capable. So you can do both sides, both the analog as well as the digital parts of eSIM. And so learning this is like a very important foundational piece before anyone starts to do either VLSI design or device design. And you get exposed to the state-of-the-art tools that are available in the open source, like Spice, GSpice, QueryLater, GHDL. All of these tools are bundled together in eSIM, which is FOSSEE's own software package. So what FOSSEE has been trying to do is to promote these tools. Sometimes the tools are not developed by us, but they're existing open source tools. But we make curriculum material. Excuse me, I have a bad cold. And we conduct many workshops like the one we have here. We are also trying to talk to various universities and see if their curriculum can include some part of open source software. And so we believe this is a great way for any engineer who just learns their basic college material. They learn this open source stack, and then they can go start their own startups or small companies. And they don't have to pay this huge tax to these commercial software companies and still be able to do EDA. And that's why we believe this is very important. And we're very grateful that the IEI has kicked this off, this series off with FOSSI. So I'm very excited that this has started, and I really hope that all the participants, make full use of this workshop series, in fact, and learns many of these open source tools that could potentially make a huge difference to your own organization and to your future. So thank you very much.
Yeah, thank you, sir, for these insights. And as you rightly mentioned, the open source tools are in academic, it has to be taken up, because once students learn it, then only it goes to the industry. And that's why you rightly said that many commercial tools are available almost freely to the academics, and we are trying to come out of that. But one thing which is very important is that as a student, when I was there, what we learn from open source is the what is behind the front end, what goes inside. Like that, you cannot learn even if the commercial software is given as a free. So that is one thing which keeps the software a unique and different.
Right.
And yes, today with eSim, uh, we are very thankful to the team for accepting us our invite, and we now look forward to hear from you on further developments.
Our pleasure, and we'll be happy to continue these kind of interactions in the future as well. Thank you.
Thank you, sir.
Enjoy yourself in the workshop.
Sumanta, you can continue now.
Yeah. So thanks to Prabhu sir for the introduction. Uh, 1 minute.
You can share your screen.
Uh-huh.
Yeah, visible.
Yeah. So yeah, now moving on to about FOSSI. So as Prabhu sir said and Himanshu said, FOSSI stands for Free Libre Open Source Software for Education, and it is a Ministry of Education funded project, funded by Government of India, and it's a government project basically. And we are based at IIT Bombay, and we are into training and skill based education. So these are all the software which FOSSI is offering. You can see Scilab as an alternative to MATLAB, Python, eSim as an alternative to various EDA tools, Floss Arduino OSDAC as an alternative. This is for structural design, and we will be having some of the webinars on Scilab and OSDAC in the later stages. And there are different other tools which one can explore on our website. And so here's a quick comparison between the tools like Scilab to MATLAB, R to SPSS. So the ones in the left hand side are the alternatives to the commercial software present on the right hand side. So similarly, DWSim, Spin Plus, Open Modelica, Diamola, OSDAC, RAM connection, and so on. So activities promoted by us. So we have different activities to promote open source tools to motivate students and faculty partners, faculty members, and also startup organizations and different other people out there. So case study project is one of them. The research migration project is another, where people submit their work, take up some case or research paper, then convert it to an open source platform, use our open source tools, then convert it into an open source domain and submit their work to us. So similarly, we have other projects. We also run internships and fellowships. So currently, the summer fellowship is going on, is going to start in mid-May. So now coming back to our topic, like why India needs to lead in semiconductor manufacturing, as Professor Prabhu said, we are lagging behind kind of, but still there are a lot of fabs getting established. So chips power is everything. As you can see, everything is automation currently, and we cannot live without digital devices. So we need economic independence, and we need to create have job markets in this area and for our national defense security and lot many other things. So this building the semiconductor manufacturing, India needs to lead semiconductor manufacturing in the coming years. Now, Indian Semiconductor Mission, so it's basically aims to build domestic design and manufacturing ecosystem and skill the semiconductor workforce, R&D and innovation, Atmanirbhar Bharat, to achieve the motive of Atmanirbhar Bharat. But the challenges are faced by us is, as we discussed earlier, the costly commercial EDA tools, which colleges, startup companies face it as a lot of challenge. If they pay lakhs of rupees of money in the commercial EDA tool, then there is a lot of hindrance in their work. So limited access in academia, they get only the free license, not the complete license, and dependence on foreign design ecosystems. Ultimately, we get dependent on foreign countries for having the access to these tools. So how our team contributes, we are trying to democratize the chip design, free access for students, and we having skill development, and we support innovation. So since open source is open, so one can just plug in the libraries and plug and play. The libraries need not be open source, but our tool is open source, so anyone can plug and play and try them out. And ecosystem collaboration, so connecting with different academia, having academia industry, Indian industry academia partnership, and startups and ISM related initiatives. So how our role is trying to align with ISM objectives. So we are trying to build this indigenous EDA tool and training thousands of learners and R&D innovation and self-reliance. So this is our team, myself, Varar, Shanti, and Aditya, and the senior managers, and Professor Prabhu Ramachandran is the principal investigator. And this project was started by Professor Karan Mudgalia earlier. So eSIM, we have developed this tool at FOSSI, and it's a bundle of tools, like as Professor Prabhu said, like KiCad, which is used for PCB design, NGSpice for SPICE simulation, Verilator for Verilog simulation, MakerChip, Verilog, GHDL, HDL simulation, VHDL simulation, and OpenModelica. And it's released under GPL version 3 license. So features of eSIM, as you can see, there are lot many things which can be done using eSIM, and we are also integrating eSIM with other open source tools like OpenRoad to have the complete chip design flow. So schematic design, SPICE simulation, digital, analog, mixed signal simulation, PCB design, device modeling, and we also have access to various open source PDKs like Sky 130 PDK. PDK stands for Process Design Kit, and Sky 130 PDK and ISP PDK, and we are promoting sub-circuit designing and support for Windows and Ubuntu OS, and yeah, so schematic converters and so on. We are also developing a chatbot for easy circuit design debug. Since circuit design is a niche area, so we are trying to have this chatbot to help users. Now we have, this is the following startup screen of eSIM. This is the schematic editor. This is the circuit, as you can see. This is the digital circuit, and rest of the blocks are analog. So this is a mixed signal circuit. So let me show you a promo video. Okay, let me move on to this presentation again. Yeah. So current activities under eSIM, this circuit simulation project, the contributor gets recognition on this website and the certificate from our team. So basically, one needs to promote to give a submit a circuit on our website, and they get a recognition and the certificate from our team. And if we have funds, then we also give honorarium. Similarly, we have lab migration project. This is for faculty members. So professors can submit, take up a lab, for example, digital circuit design, and do the lab using our tool and submit them on our portal. Okay, then eSIM Marathon. So this is a 1 month hackathon activity. So basically, it's a rigorous activity where students, people from various domains, including students, startups, then experienced people from industry, and even professors throughout the world come here, join us, and try out various things. So there are various circuits, and so we have a different topic. So for example, in 2021 we had a circuit design and simulation marathon. So every time we have around 2000 plus participants, and it's a great area where different people collaborate and talk together and explore a lot of things, and there's a huge scope of knowledge exchange. So this is a wonderful platform, and the outcome of this marathon was around 10 designs we taped out, we had sent for tape out, so basically for fabrication. Now, research migration projects, so reproducing already published work using eSIM. And yeah, so this is another project like circuit simulation project and lab migration project. So one can submit their work, they can and they need to take up a paper and then submit their work. And once it gets approved from our side, they can do it using eSIM. And yeah, so one gets recognition on our website and the certificate from our team. So we also provide fellowship internships. So fellowship 2026 is upcoming in this mid-May. Semester-long internship is currently going on. Around 40 interns have joined us, and for fellowship we have around 60 interns. So yeah, and previously also we had many interns who had done wonderful work, and they get placed after this internship. They upgrade and get placed in various reputed companies, and they also move on to higher studies. So conducted activities under eSIM, we conduct workshops and conferences like this one. So this is one of them. So one can explore the website on the following link given, our eSIM website. And learning eSIM is made seamless using spoken tutorial videos. So one can check it out here on this following website. So our outreach, yeah, so 2000, so in the marathon, we have around 2000 plus registrations, around over 100 winners, and around 9 designs. And currently one was sent to HP. So currently we have 10 designs sent out to fabrication, and they got fabricated actually. And a repository of 600 plus circuits contributed from India and abroad. And yeah, so we have currently 100 plus, actually 200 plus. After this fellowship it will become. Then we have, so this is the quite rough statistics which we took from the students, whatever they are doing currently. And yeah, so we also conducted a hardware workshop in 2019 where around 3,000 plus participants were there. And this was to compare, like, compare the results of compare the analytical versus simulation versus the practical ones. Okay, so a hardware kit was sent to them and they compared the three results. So our outreach for the circuit simulation is around 350 plus submissions we have throughout the country and abroad. As you can see, there are different institutions who have participated. And interesting stories. So earlier eSIM was named OSCAD, but PSpice got worried and asked us to change the name since it sounds similar to their proprietary tool ORCAD. So such was the impact of eSIM, and yeah, we changed it to eSIM, not to get into legal issues, but yeah. So even PSpice told us to change our name. So OSCAD became eSIM. Similarly, there are various success stories of placements and study abroad and different other things. As you can see over here, how our internship and different workshop activities have helped the students. So our collaborators, our own FOSSI team members, then like collaborating with other teams, HOSTAG and so on. Then undergraduate, graduate researchers from all over the country and abroad, and and various industry partners, coordinating with teams of Swadeshi processors like Ajit, Shakti, and Vega. We earlier collaborated with Google Skywater. We are also connecting with IHP Fabrication, Germany, and kind of we are part of Indian Semiconductor Mission. We are also collaborating with SemiX, IIT Bombay, and reaching out to many other open source fabs. So these are the GitHub repository links. I would request everyone behind the scenes to everyone watching this webinar to this just scan this QR code and check out our repository and explore the eSIM source code. If anything, you can reach out to our team if you have any difficulty in understanding the source code and so on. So thank you. So feel free to contact us at contact-esim@fossee.in and join the hands in developing eSIM. So we have something in computer science domain and we have electrical domain. We want eSIM to be on every platform, including whether closed source or open source like Windows, closed source like Windows proprietary, or or for example Ubuntu open source platforms like Ubuntu or Kali Linux or all the Linux distros, and even on Mac installer and different other platforms. We are also building a cloud version of eSIM so that eSIM is accessible to everyone without even installing it. We are improving the UI. We are planning to have our own schematic designer tool. So instead of KiCad, and definitely, we are also building plugins for KiCad. For those, we need computer science people. Then fixing bugs and integrating with Open Road toolchain, which is a RTL to very famous RTL to GDS2 tool. So we are integrating it with Open Road and tool manager development and different other development related tasks. So develop chatbot is one of the tasks which is of the interest of people who want to have their career in AI ML. Now, design ICs, electrical domain, so design ICs, the sub-circuit designs, then digital system on chips, design system on chips, then power devices integration, RF components integration, device models, create VLSI IPs, simulation for tape out, and testing. We need a lot of testers. So yeah, do join the hands with us. So let's move on to the hands-on demo session carried out by my colleague Varad Patil, who is a research assistant at IIT Bombay, at FOSSEE team at IIT Bombay. So over to you, Varad. Varad, are you there?
Yeah.
Yeah, along with Varad, Shanti Priya is also there, who is also a research assistant at IIT Bombay. Yeah, so yeah, Varad, so I request you to continue.
Yeah. I'm audible to everyone?
Yeah,
Yes,
you're,
Swaraj.
yeah,
Welcome to you both, Vad Patil and Shantip Priya, to this webinar.
I think there is a slightly network disturbance. Is it for everyone or for me only?
we are able to hear you.
Okay.
But your voice is very low. I think you can
Okay.
keep your mic little. Yeah.
Mm, Yeah. Is it okay now? Hello.
No, yeah, you are audible, but very low. You can be little loud.
Yeah. Is it okay now?
Yes, yes, this is now perfect.
Okay. Okay. This is fine, I guess. So, may I introduce myself and then we could see an example how eSIMs actually looks. Hello.
Yeah, please continue with your video.
Yeah.
Yeah.
So, hello everyone. I'm Bharat. With me, my colleague Shantipriya. I'm working as a research assistant, and before joining here, I was trained at ISRO Space Application Center at Ahmedabad, where I work on satellite communication division. With prior goal was to establish many SPI um, interface, like communication interface using with some LMX and some like two frequency synthesizer and some channelizer. So that was like something which was more related to electronics, and then I joined here, and now I'm a part of the eSIM team. I believe my work will be much adequate here. So uh, before I start, I will just share my screen. I hope the screen is visible to everyone.
Yes, visible.
Yeah. So basically this is the eSIM interface when we install eSIM and open it at the very beginning. So this is the interface, you could say. It is about eSIM. eSIM is an open source CD that we already discussed about. With this GUI has the beginner or novice can easily understand how to use this UI. The left side, it is to create your own schematic and then other functionality. Before going one by one, I will just quickly create one project so that we'll get to know how to get these things done. On the very top side, if you could see my cursor, that is a new project. Once I click here as a new project, I will just type RC and then eSIM. I will just hit enter, and you can see there is a new project got created, and parallelly on the eSIM GUI you could see there is a command line, so we can see what exactly happening throughout this tool. So once the project has created, we will just double click on that to open it. And so project has multiple files within that, so we'll come up with first thing, that is a schematic. So for schematic, on the left toolbar there is a first option called open schematic. Once you click on that, it will open the schematic window to create your own design. At the very beginning, it will ask you for the confirmation. You will just click yes. And now for there are many libraries that we actually included in the eSIM. So we'll see that. For that, at the right side, if you could see, there is a add symbol option. That is nothing but to add all of the component. Once we click there, you will get this beautiful GUI for adding all of the component. So we'll just see one small RC circuit to see how it actually perform. So I will just take a pulse first, and I will add it here in the schematic. Parallelly, I will again press A on the keyboard so to add more component like a resistor. I will add one capacitor. I will add one ground. So this is the basic component which is needed. So I will wire it up. For wiring, we'll press W to get a wire on our cursor, and I will just join everything. I hope my screen is visible to everyone, and I will just wire it up. So now schematic is done, but we need to see it how actually it is performing. So for that, I will add some plots. So plot is just to see what exactly happening on that branch. So this is a plot P1. I will copy it once again, uh, and I will just again wire it up. Okay. So visually it is done, but the values for the resistor, capacitor yet to be decided. So you can see there is a R and question mark. Question mark is for annotation. Once it annotated, it will disappear. To add the values, I will press V on the keyboard to add the value. So I will just keep it as a 1K, 1 kilo ohm. And for the capacitor, I will again add it like 10 micro. So now the values are done. So we will move toward the annotation part. To annotate, on the top bar, you can see there is the option called fill in the schematic symbol reference designator. So once we'll click it here, and we'll get to know there is annotation. There are many patterns we can perform for annotation. For now, I will just simply annotate. So annotation is complete. at the end. So now you can see the question mark which was earlier appearing is not no more. It was like R1. If there are multiple register and all, we can map it according to the sequence like pattern and all to annotate it better. After this is the schematic. Now we'll go for the netlist. To create a netlist from the schematic, I will click on File, Export a netlist. For netlist, I will make sure it is a Spice netlist, and I will just export. While exporting, we no need to change any name, so everything will be saved in the parent folder of the project. So you can see this is the project that we are working on. So I will just refresh it once to see my CIR file is now created. To give the more in-depth parameters to analyze, or we could say the variable parameters. As of now, the resistor and capacitor we get it fixed, but pulse that we added it not. So we keep it variable just because for our convenience. So I will click on KiCad to ngSpice. That will be used to make the analysis for this design. So there are three types of analysis: AC, DC, and transient. So we will go with transient. I will just put the parameters like we'll starting from 0, and then we will go up to 100 millisecond. And what we'll do, we'll step it for 10 millisecond. That is the one thing. Other, the source detail, whatever thing that we didn't fill, that will appear here, and we will add it like we will start from 0, then we will make it up to family. We will not add any delay in that. We could add, but as of now no need. And one more thing that need to added in the circuit is the global level. So basically what happens whenever we create any branch, that time it don't have any name. So our basic practice is to at the global level. So what I will do, I will just add one wire here and one more wire at this place, and I will add a global level at this point. So let's make it as a one one as in, and I will add it here, and other I will keep it as out, and I will add it here. So now you can see the branch is now. I will just again add the netlist, export it again. So now if output comes within this area, it will be annotated as in. So it is for our understanding. Yeah. So we'll keep it as same. We'll do it in milliseconds, and source detail will keep at a 0, 5M, 0. Delay rise time will keep as a 0.5M. It's on us, so we'll be running on 50% of duty ratio. So up to this, we added detail, source detail, and analysis factor, and ngSpice model, device modeling, sub-circuit, and microcontroller. In this particular example, it was not included, so these are the vacant. If we added, we need to make the changes accordingly. So we'll convert the netlist now. And this third option is for the simulation. I will click it here. It will ask you whether you want the ngSpice plot for the same or not. eSim has two plotting methods. One is ngSpice, which is very strong and very reliable, and parallel we have Python plotting. I will just click yes, and the simulation will start. At the end of the simulation, we could see there is two plots. One is the input and other is V out. So this generated using ngSpice, I will keep it as it is, and I will show you the Python plotting which eSim has the feature. So I will just click on in, and then I will click plot. So you can see this is being created. So for the sim, and for ngSpice, what we can do, we can use it more effectively using this command line. So I will just show you one thing that how to use that. I will just type plot Plot means to plot whatever we want. So plot v in and then plot v out. So after this, you can see both of the waveforms will come in the same plane. If you want to compare it exactly, like we want to see one of the one to be the top of other, I will just add one plus and I will drag it up. So now you can see the one is in between, and this is for the reference, like if you want to compare it. So this was the circuit that we just tested out for the flow, to understand the flow of the eSIM. And I hope my voice is clear.
Yeah,
So
it's clear.
yeah. So this is the basic functionality from ngSpice, that you can control whatever things you want from this command line. And in case you don't want to use this, eSIM has the Python plotting, so you can change it from here itself. If you want to change some layout and all, you can export that thing, and if you want to save, all is here. And if you want to see the multimeter reading for RMS value, you need to click here once, and for the same node, it will be get generated. So this is the main eSIM GUI, and that's all from my side.
Yeah, Himanshu. So
Yeah, so we can have now open session for any questions from participants, or if anyone would like to understand something. If you have any questions, you can raise your hand. We will unmute you and you can talk to us. Okay, we have one question from Mr. Mohit Kumar. Yeah, I have unmute. You can unmute and ask your question, Mohit Kumar.
otherwise, I may answer him. May I?
But where is his? Okay, yes.
Is it
You
possible?
can.
Is it possible to simulate circuits like SCR? Yeah, Adityanath. So it's possible to simulate SCR. All kind of power devices can be done. SCR, then UJT, and all can be done in eSIM. Any other question, Himanshu?
Yeah, Shiva Kumar.
How better is this open source than existing PCB design software? Yeah, so we didn't do a comparison. However, you may find some papers. We are using KiCad as the PCB designing software. So KiCad is widely used by many PCB designing. I mean, even companies, good startup industries. I mean, it's widely used. So it's good enough to do multi-layer PCBs. So I hope this clears your question, Shiva Kumar.
Yeah, and to add on that, like there is actually it should be viewed in a different perspective. Like when you are working with open source, you have the ability to modify the things in the source code itself if you want something advanced level. But otherwise, it is a free software, so you can always use it without any commercial obligations, and that's one of the benefit you can understand.
Yeah. And
Okay,
then, yeah.
Mohit Kumar is having another question. For complex circuit, it shows an unexpected error. Any insight how to avoid them?
Can you give more insights to the unexpected error? Like, so basically there are, so in the background screen, so there are logs captured in the eSIM. So you need to send it to us, mail it to us, then we will have a look. You can send it to us on contact eSIM at the rate.
So I understand that would be very specific, and you can always send your circuit design to us with what error you are getting. So team will be able to help. The email ID is given in the message box. You can send it on this email ID. They will respond.
Mhm.
Another is Akash Yadav. I am BTech EC student entering fourth year in May 26. Which skills are most demand in the industry?
Yeah, so basically, this is a bit off track question, but I would like to answer you. Like, it depends on your interests, basically. So, from a EC perspective, you can go into communication, you can go into VLSI. VLSI is a booming field still. So definitely with an AI, ML, if you can do some neuro related chips or something like that. So yeah, it's a good place, VLSI design. Okay. I hope this clears your question. You can contact me personally or sometime or to our website and ask this question. We will give you some insights.
We have two more questions. Is Skylab use same language as MATLAB?
Uh,
This is a different question, and we have a separate session on Skylab in the coming week. So that time we can take up. But if you can answer in one line, Sumanto, if
yeah. So Scilab is similar to a MATLAB. I mean, it uses the same language. You can please do attend the session coming in the upcoming week. It will be very much helpful for you.
okay. And one last question is that eSIM in VLSI design. I do not understand this question, but are you asking that uh, is eSIM in VLSI design? How it is?
Yeah, so we do so as I said, we are integrating eSIM with an open source RTL to GDS tool called OpenRoad, which will have the complete RTL to GDS2 layout design in terms of digital flow. And for eSIM and in terms of analog, we also already have this Sky 130 process design kit integrated with eSIM. So also the HP. So you can work on the following PDKs, and yeah, so it can be used for VLSI design. I mean, at least up till the simulation step. Yeah.
Yeah. So, okay, with this, I think there is no more questions. So, thank you very much. I would like to thank Mr. Sumantoka and Mr. Varad Patil for this insightful session. And a special thanks to Dr. Prabhu sir for joining today and giving us insights on how this software is using, benefiting our semiconductor industry also in the Atmanirbhar Bharat scenario. I thank Institute of Engineers India for providing this platform, and through Institute of Engineers South Gujarat Local Center, we are hosting this session. So thanks to our chairman, Dr. K.D. Panchal, for providing us all the guidance. I am Himanshu Bhatt, Secretary, IEI Surat South Gujarat Local Center. And last but not least, thanks to all the participants for joining today and for this session. The YouTube link is available. So in case you want to recap this session, you will be able to see those details on YouTube. Thank you very much. Have a nice day. Good evening. Goodbye.
Thank you. One last announcement to the participant. Those who want to have the participation certificate, webinar certificate, they can register themselves and pay a small token of 300 rupees, and they will get their registration their webinar certificate within 3 to 5 days. Thank you. Thank you all. Thank you, South Gujarat Local Center, for hosting this nice webinar.
Thank you, sir. Saurav sir, I would like to talk to you after this webinar. If possible, please give me a call.
Okay, okay, no issues. Thank
Thank you all. Nice day. Bye bye.
Thank you. Thank you, Himanshu. Thank you, IEI.